Welcome to episode 13. Today, we're going to talk about some other industries or the nature of business processes that might be good for the type of AI that Daisy is doing. We've talked a lot about retail and talked a little bit about insurance. Those are some of the use cases that we're doing is kind of automating some decision-making processes. So helping retailers with merchandise planning and kind of automating part of the merchandise planning decisions and then automating claims decisions, so claims adjudication and fraud detection. So those are the processes we work in. And I think the common characteristics of some of the processes that are really useful for AI to help out with would be things that are rich data, lots of information about the process. So you think of retail, you have a typical grocer might have 50,000 products. And if your goal is to choose 2,000 products out of 50,000, there's 10 to the power of 3,600 possible choices. So this is a massively quantitatively complex challenge to choose the optimal combination of products. So that's a great example. Tons of data. We have a lot of retail T-log data to support the decision making and have our systems learn the dynamics of retail. The process is continual. The retailers have to make these decisions every day, every week. They're choosing items, setting prices, both regular and promotional prices and markdown prices. So it's a continuous process, making millions of decisions every day, every week. So those are what we would classify as a business process beyond human ability. And it's very quantitative. So huge volume of decisions that occur on a regular basis. And the decision-making logic can be very quantitative to optimize something like the optimal mix. Similarly, in insurance, a large insurance company might have tens to hundreds of thousands of claims coming in every day. And to assess whether you should pay a claim or not pay a claim, you can't simply look at one claim file or a quote request and in the context of that one piece of data alone say, yes, I should approve this quote request and write a premium. I can assess how risky it is, or I can decide to auto adjudicate. I can pay this claim, or I can deem that it's fraud or not fraud. Again, now the complexity comes in. We have to compare that claim to every other claim ever seen. And if insurance company might have billions or hundreds of millions of claims, at least that you've seen in the past. So again, a human being having to make 100 million mathematical comparisons to say, is this claim out of the ordinary compared to other claims? Is this quote request out of the ordinary? Is it risky doing perhaps predictive analytics around building a model, looking at the model score, and is that sufficient? So the idea is, again, a business process that has to happen. It's relentless. It's every day over and over and over again. And it's highly quantitative and mathematical and really beyond human ability to do the mathematical computations necessary. So we would say for the brand of decision making that Daisy does, and I think that's a great place for AI because I think that divides the world in two. As I said, our mission is to elevate people and let computers do what computers are good at. And we call them computers because they can compute. So the two examples I gave were highly computational and quantitative, and the computers are great at that. Computers are great at applying systematic logic over and over and over again. And with the power of computing rising every day, we can do more and more computations, whereas people are very good at ambiguity, creativity, interacting with other people. So the nature of the things that people or computers are good at are very different. So we look for problems that are beyond human ability or quantitative problems that aren't being solved today. One of the challenges with tackling a process like merchandise planning or claims automation or fraud detection is that there are processes in place today and people are doing the job today. So that's difficult for companies to make the change. Even though you may be able to do it better, the fact that it's happening today and these companies have priced their inefficiency unless there's a real need to act and improve the process, it's a difficult sale. Whereas we can apply price optimization, let's say, to e-commerce websites. That's typically an automated exercise already, where you might be scraping competitor websites and price matching. And so updating internet prices, typically on very popular e-commerce sites, you might be updating prices multiple times a day. That's already out of the realm of people, and we've applied some technology to that. It's price rules-based logic, and now moving into AI pricing. So that's a great candidate. It's a computational and people aren't doing it today. So the challenge is, even though it's very computational and complex. If there's people doing it today, then we run into this challenge of how do you do the human change management. So looking for highly complex quantitative computing problems, ideally that people are not doing today, that's a great candidate for AI. And so we can think of e-commerce price optimization as opposed to price setting. What they might call dynamic pricing is not necessarily AI-based price optimization. It's typically price rules and price scraping from competitor sites. So moving up to applying AI to a case like that, that's an excellent case. Certainly going into healthcare, that's an area that we've done a little bit of work in diagnosis. We've heard a lot about deep learning being used for MRI images and now generative AI being able to summarize a lot of medical research and present it back to doctors. So that's a great example of a use of generative AI as well. You know, that doctor goes to school, you get an education, but the literature and research keeps on progressing. So how, as a human being, can you possibly stay on top of all the new medical research that comes out every day? I think generative AI, using that to summarize the medical literature, I think that's a great example of something that can help a person. And that's a case where human and system can collaborate, where the generative AI can summarize new research and findings for a doctor. The doctor can then drill into the areas that they feel they need to learn new things. And so that's a great example. Again, a huge data problem, huge volume of research, volume of information beyond a single human's capability to digest it all. I think that's where generative AI can help summarize that for a human being. And, you know, applying AI to help make medical diagnoses. Again, we could have large databases in our healthcare system. Canada here with the provincial healthcare systems, there's millions and billions of visits to the doctors. And in the US and the private healthcare systems, you see billions of records of doctors' visits, diagnoses that have been applied, procedures that have been applied to the patients. And over time, we can see patient outcomes. So again, having a huge longitudinal database of diagnosis, treatment, outcome, that's a great place for AI to go in and analyze to say, what are the most cost-effective treatments that could generate the best outcomes? So we can use this to guide medical practice. You might see 10 different doctors with the same condition. You don't necessarily get the same diagnosis, the same procedures, or the same outcome. And so this is another great use case of AI. Very complex, huge volume of data looking at the efficacy of medical diagnosis and treatment. No individual doctor could look at the database of all of the treatment that's been done, but in some of the large healthcare organizations, there's years of longitudinal healthcare data that could be then analyzed to find out and answer what are the best treatments. Again, cost effectively. We know cost of healthcare is rising dramatically every generation. And so being able to be efficient and have great outcomes, trying to find those two things, that's a great example for AI to go in and be applied to analyze that data, whether that's purely machine learning or statistical analysis or another branch of reinforcement learning, taking that whole data pool and trying to figure out what if we applied the best treatments, what can we simulate the possible outcomes and the cost savings and the improvement in health that we get. So healthcare is a great area to apply this. Similarly to insurance, banking, there's a lot of fraud in banking. So doing fraud detection in banking is very similar to things we've talked about. Doing credit risk analysis, again, very similar to insurance risk. So that's an area that AI has been applied in for a long time. A lot of predictive analytics around credit approvals. Again, a very complex data-rich environment. Looking at telecommunications data, so analyzing cell phone data, so looking at all the text data, all the call detail records, gigantic volume of data in the telecommunications industry, looking at all the calls, analyzing, again, things like dropped calls, people with handsets that are defective or slow, done use cases like that, where we can say, what are customers who are experiencing a lot of call drops, for example? Should we replace their phone because it's broken and they're paying more than they need to because the phone is not operating properly? Or looking for opportunities for charging intercarriers. You know, when you make a call from one phone to another, if you're on different companies, the phone call traverses multiple networks. And we know there's lots of lost revenue in between corporate networks. And so again, helping companies recover the lost revenue makes them more profitable, which makes it more likely that they'll be able to lower prices. So again, telecommunications, huge volume, literally terabytes and petabytes of call, text, email information flowing over those telecommunications networks. And there's a lot of things that can be done with that, as I said, around optimizing the service, around deciding where to extend the network to offer more service in places where there's lower density. So optimizing network capacity. Again, all these are highly computational problems. In the case of telco, there's people doing this manually today, but I think in a big way, I think that's an area where there's not a lot of people working. These are great use cases. So again, to summarize, I would say let's go out to look for places where there's huge volumes of data and these data rich industries, retail, insurance, banking, telecommunications, government. And those are the places that we could look at the business processes, look at the decisions that are being made. So the decision on whether to promote an item or not, charge a certain price or not, whether to approve a credit card application, whether to approve a wire transfer from person A to person B, whether we should grow the telephone network, whether we should diagnose a treatment or a disease or an illness. All of these are decisions that are happening today, and we can optimize those decisions by taking advantage of AI, whether that's generative AI to help summarize information for a doctor, or that's kind of machine learning or predictive analytics based AI to kind of predict an outcome, or whether that's reinforcement learning or simulation to simulate the environment to say what's the optimal decision-making policy given the dynamics of the system. So when we're looking for opportunities for AI, those are the things that Daisy's looked at in the past. As I said, we've talked a lot about retail insurance. We've also done a little bit of work in healthcare, doing medical diagnosis for patients with mild to moderate brain disease or injury. We've done that for one of our clients, had a clinical application that was applied in a clinical setting to patients, a tablet app that did 60 tests of a person's cognitive abilities, would measure their vocabulary, mathematical comprehension, their dexterity, their balance, their hearing, their memory, speech, all of these things with multiple tests done in a clinic. And then the DAISY system analyzed those tests against a benchmark of what is normal. And we found all the deficits that a particular person had. And so mild to moderate brain injury, there's not a lot of great diagnosis in the medical industry. It's more for people with severe injuries that get treated well. So, looking at concussions or some kind of illness that would cause some mild cognitive impairment, the DAISY system was able to find what are the cognitive deficits. And we did collaborate with some medical researchers and analyze the data of women who had had heart attacks to see was there a brain difference between women who had heart attacks and women who didn't have heart attacks. And there's a patient population of on the order of 60 to 70 patients. And Daisy was able to uncover certain cognitive deficits associated with heart attack by analyzing the output of our client's clinical application. So that's a great medical application there where we're, again, comparing the measurements from one person to a benchmark pool of data for people who are healthy, as well as your own benchmarks if you collected your benchmark before illness or injury. So again, that's a great use of outlier detection, complex AI-based, reinforcement learning-based outlier detection in medical illness, because medical diagnosis to some degree is an outlier detection problem. Are you different than the norm? Are your medical measurements different than the norm? And those differences could be caused by an illness or could be caused by an injury. And so that's another use case there. So hopefully that helps. You give that, highly quantitative, never relenting, constant decisions required. I think all of the processes I outlined today are things that keep marching on with time, and I think are great places for AI. And I think if AI can improve the efficiency of those processes, it'll reduce the cost of executing the processes, increase the efficacy of the processes, which I think ultimately will lower the cost of delivering those services. And only good things can come from lowering cost. It causes lower prices and ultimately lowers the cost of living. Those are the types of processes. And typically these are things that human beings are not good at, that computers are good at. Again, dividing the world into let's let machines do what machines are good at and people do what people are good at. And if we can do that, hopefully we can minimize the impact on human jobs and labor. So thanks very much for tuning in. Again, if you enjoyed this, please subscribe to our Spotify or our YouTube podcast link. And if there's any feedback or questions that you have, feel free to follow up, and happy to answer questions and feedback on future episodes. Thanks so much.